Let's get started. Right, welcome everyone to the Flyte community meeting. Today is June 13. I'm David Espejo, and I'm happy to be your host today. So the first thing I should remind you that this meeting is being recorded, and the recording will be posted to Flyte's YouTube channel. And the next thing is this meeting, as every other communication channel on the project, falls under Linux Foundation's Code of Conduct. Great. So I'm sharing here again the link to the agenda, and I'll ask for you to add yourself to the attendees list. I'll add my name so you can see how it looks. There you go. And yeah, with that, let me see if there's anyone joining for the first time. I'm not sure, brother. Is this your first time, brother Peters? Is this your first time in this meeting? And sorry to call you out if you're not available. That's totally fine, but welcome to community meetings. Great to have you here. Also,
I'm also joining for the first time, so can also
yeah,
put me on the list.
As
great,
am I.
Mark.
As am I. Yeah. Peter here.
Yeah, Peter, that's great. Let me are here, Marcus, Peter, and that was there you go. Awesome. Great to have you all here. All right, let me share quickly my screen right here. I hope all of you have access to the agenda. It's right there in the invite. So today we're kicking off a small section at the beginning of the meeting, news from the ecosystem, from the ML data ecosystem. It's meant to be crowdsourced. So if you know of anything relevant that happened during last week or last couple of weeks, feel free to add it there. We can comment briefly. So with that, I'll start with the OWASP Foundation. They're working on a top 10 vulnerabilities list for LMs. It's in the draft state right now. It's open for comments. I believe it's July 1st, the day they have decided to publish a first version, but for now it's open for comments. It's interesting, many of the artifacts that the OWASP Foundation releases are top 10 vulnerabilities for different software stacks. And there's been a lot of comment around this one. Some people think that, yeah, this is just general software best practices just translated to LLMs. Some of them think that it has a lot to do with sandboxing, proper sandboxing, etc. But again, the thing is, to give a first step, trying to define the big issue on responsible or secure AI. So it's open for comments. The Slack channel for the foundation is open for you to join. You can join the meetings, comment, learn, etc. It's similar to a project that they already have released, the ML top 10 security risks or vulnerabilities. That again is open for anyone to improve. And finally, in the security world, the Mitri, because I'm not sure how to pronounce this well, they release also a draft. As you can see, this is a very nascent field, very early on the development of security best practices in AI. Everything is in draft right now. So Mitri, they release this draft of mitigations for different ML vulnerabilities, very much aligned to what the OWASP Foundation is doing. So kind of trying to give the next step. Okay, if this is the top 10 of vulnerabilities, what we can do about it. Right. Okay, and probably I should have put this in the top because also related with the security side of things. Google released first attempt of defining a secure AI framework kind of a set of steps. I think they have a nice document. It's over here on how practitioners can get started on securing an AI pipeline. It's not complete by any means. I mean, just 12 pages of recommendations, like many other standards. They define the what, not the how. But it's a first attempt to try to tackle a big problem. All right, great. Next up, Databricks announced MLflow 2.4 release, including MLflow Evaluate to assess the performance of language models. Also a new artifact view, a way to compare input, outputs, and intermediate results across multiple models. And finally, the dataset tracking features, a way to identify which datasets were used to develop and evaluate each of your models. All right, and finally, interesting and at the same time, yeah, probably fun to try. I believe they are from Meta, from Facebook Research. They published a paper and a set of samples. It's all there in the link. A music generator. Probably this is not new, but according to the authors, what is new is that they use a single stage transformer together with efficient token interleaving patterns. And in summary, it could be more efficient. So the paper and samples, code, everything is there for you to try. Okay, up to here. Any comment, any other news that we're missing? Oh. All right. Yeah, again, feel free if you for the next meeting, if you are aware of anything that's happening out there and you like to comment here or share, feel free to put it there. Awesome. Next up, on community updates. Kineo.ai is sponsor for the Toronto Machine Learning Summit, and some community members are there. Yesterday, Niels Van Tilland, part of Flyte steering committee, he gave a workshop on fine-tuning on Flyte, and there will be also a roundtable with folks from the community. It's not charging. A roundtable on LLM ops. Yeah, we're using that term, LLM ops, and why it's relevant, how to approach this big concept. And you can find it there. I don't know what's happening with the website, but yeah, in the roundtables, I believe it's roundtable number 16. If you happen to be attending, it will be there. There you go. Yeah, you can see it right there. LLM ops, because probably that's a thing. Great. Next up, seek out. As probably some of you already are aware, the Flyte governance model now includes working groups and special interest groups. And to tackle project-wide concerns, the model defined the idea of special interest groups. There's an issue that our good friend Honix from Spotify, he created, kind of trying to take the next step on the auth experience in Flyte, support more providers. And probably this is a good kickoff issue to go over the idea of having a auth special interest group, because yeah, there are many options here, many potential providers, and it will be great for the community to have a say and to lead. So the call to action here is to go over the issue and comment if you also like to see a SIG auth. Yeah, leading a SIG is not really a burden. It's a matter of facilitating communication, but it's more over trying to define a set of sub-projects, at least a sub-project. First goal for the SIG to gather a part of the community together and think and produce something around extending or improving the auth experience in Flyte. So Right now, it's open for you to comment and consider if this is something you like to see happening. Seek out. Right. Next up, in terms of roadmap / release updates, I think I saw Eduardo here. I don't know if you wanted to comment something.
Yeah, for sure. Let me do it real quick. So we're getting 1.7 out today, or just making sure that it's in tip-top shape. We're announcing a renaming of a feature that we had it in the works previously. It's this idea that now you'll be able to write plugins for the engine in Python. We're calling this Flyte agents now, and we're planning to expand this idea massively. So the first version is going out with Flyte 1.7, but we're just gonna extend this this concept in 1.8 and beyond. So keep in touch. It will be you see how this tight feedback loop where you can go from your local machine all the way to like running a plugin in a Flyte deployment in a much simplified manner. But that's not the only thing that we're working on. We also heard the community, like there's an RFC related to tags or execution tags, so you'll be able to tag executions with specific labels so that you can query for them in the future. There's an RFC in the works, but being the engineers that we are, we just want to experiment to see like how things are. So there's already a PR in the works also, and we're planning to get the RFC approved and also the at least the V1 of this feature soon in 1.8. We also briefly touched on this in recent presentations, this feature that we're calling eager mode. Also, like we heard a lot of feedback from the community where there's some confusion around like how to work with the Flyte DSL in workflow. So we are proposing an extension to how you can build your DAG using Python's async like keywords. So yeah, and I think that one of the features that it's been a constant source of pain, and I'm so excited that the community jumped in to fix this problem of like how do we use data classes or how we expose data class usage in FlyteKit. So Eli, Greg, like there's a lot of people involved in this effort, and I hope we can get it in for 1.8. So yeah, lots of things happening. Like it's amazing that the community is just looking at problems and proposing solutions and iterating, and like it's awesome. Thank you so much.
Right.
Yeah, David.
Great to know. Thank you, Eduardo. Any question, comment around the new release? Nope. Okay. We'll move to the next item. So we have two, not only one, we have two guests today who will share their knowledge with the community. So I'm happy to welcome first Prafulla. Thank you for joining. Thank you for sharing what you know. And yeah, I don't know if that's part of your presentation, but will you mind briefly introducing yourself to the audience and probably sharing something you enjoy doing outside work?
Hey guys, this is Prafulla. I have been working with the Flyte community for almost like 2 years now. I started with the open source contributions, then moved to some of the core functionality, and now working on the cloud offering. And yeah, and mostly I do love to go on hikes. I live in the Bellevue area, and I love hiking around here, and it's an amazing place to hike in these. Okay, with that being said, I'll just start my talk regarding how you monitor your Flyte workflows. This will be more focused on resource level monitoring. Let me share my screen first. You guys see my screen?
Yeah.
Okay, cool. So this talk is going to be focused on resource level monitoring, but we can extend it to other levels of monitoring for specifically Flyte workflows, or in general, like any sort of workload that you run in a kube cluster, like how do you monitor those? So I'll just go over like a general ways why you need resource monitoring, or is basically like if you're running your workflows and underneath you have like infrastructure being provisioned or deprovisioned, you want to know like how much money are you spending on that? Like if you have like heavy workflows which are requiring GPUs and you're not consuming any of those, and underneath like you have some automation kicking in and spinning off new workloads, so that could be cost prohibitive sometimes. So understanding the need of how much resources you need for your workloads is crucial. And along with that, like sometimes it's very necessary for you to debug some of these failures that happen. Like it might be like you do not have enough memory to run your resources. You're running into out of memory exceptions. Like figuring out that like what is causing it could be helpful, and what is a pattern of your memory allocations would be good to see, like whenever you have any workload running, understanding that pattern to debug such failures. Another thing is like in specifically in the Flyte world, like you have each of the executions are versioned for the launch plan that they use. So if you have been changing your workflows a lot and you want to be able to compare like the resources across versions, like it would be crucial to understand like what exactly caused a change. Like suddenly you have more memory or CPU being used. So what change across versions of your workflows could be crucial to understand. So that's why you would need some sort of resource monitoring to across your Flyte workloads. I just go over like how you do it right now in your in Flyte world. Is basically you have a decorator in your task, and you specify how much resources you're going to be using, and this translates into the Kubernetes world of how it specifies the resource and limits for various resources, and you can also specify GPUs in here, and you have Kubernetes constraints of resource and limits being respected whenever you have your Flyte workflows running. So you could always imagine like if you're consuming some of these, if you're over consuming resources, then you would have your Flyte workflows running into OOM issues. And so how do you exactly choose some of these resources? So some of the existing paradigms, like people just use whatever, if they're using some post from an internet or a blog, and an example sorting algorithm is something that they will use whatever is available from the author, and they use that, and or they just pick a good enough number to iterate on. And usually what happens is then you start iterating on your numbers for your resources, and until you find the right number to run your workloads, you keep changing those. But it would be good to have like a useful data to understand like how your workloads are behaving, to right size all your requests and limits for your various resources in your Flyte workflows. So this is usually like how the memory allocations, and like I picked one of the examples like where the workflow is having a certain configured limit, and you have you have a request being specified, and then it constantly has an increasing memory, and then it reaches the limit, and where Kubernetes just crashes. It just terminates the pod because it's consuming more resources. So having such a monitoring helps to understand how you're consuming resources and what exactly do you need to change in your workloads. Understanding the pattern of your allocations would help a lot. And as I mentioned earlier, this is also helpful across if you are working across different versions of your workflows. Like you have a version 1 against version 2 of the workflow where you have more utilization and you're getting some of the workflows are becoming cost prohibitive. So he can keep history of your resource utilizations and compare those to see what change. Now, I'll just go over like how do you go about some of doing some of these. Like you could design your own monitoring solutions, and there are different ways you can do that. There are cloud providers like Grafana, Datadog, Splunk, which have their own version of monitoring. They usually have like agents that get installed in your kube cluster, and you have like a configuration which allows you to scrape your workloads, and then it has a remote write which actually publishes those metrics into their cloud solution, which has a which are persisted. It comes with its own visualization. It's a managed solution, so you have lower maintenance of doing any of the maintaining that solution. Usually the disadvantage is the cost basis of these solutions, which is like the amount of metrics being sent to the cloud provider is usually how you get built on. Another way is you just build your own solution. You just you have most of these are underneath. There would be monitoring solution like Prometheus, and you could have it managed on your own in your Kubernetes cluster. Provide a persistent mechanism if you're requiring a data durability, and out of the box, like there are open source tools to actually visualize these metrics like Grafana. Prometheus has its own UI as well. Now, whenever it comes to the Flyte world, you want to be able to understand how to map your Flyte workflows to the Kubernetes pods underneath. Like, as you know, like each is a Kubernetes solution, you have all your workflows underneath would be spun up as Kubernetes pod by Propeller. So you would want to understand how this mapping exactly happens. This is one of the examples, like how some things can go wrong if you're not properly configured your monitoring solution. This was something that a Datadog built for Coinbase, where they had been emitting metrics, and that metric emission, like you had like a huge bill, which caused a big roar on the community. So having like right sizing and control over what things are being sent to the cloud, or even in your local monitoring solution, is very crucial, and also utilizing enough resources for your monitoring solution as well. Here I will just go over like how do you build about like a self-hosted solution. Like you can set up Prometheus in your Flyte cluster. There is an open source community version which has its own published Helm chart available, and you configure it to scrape some of the metrics. Like you have Kubernetes state metrics is another open source version which gives you information about like the different cube objects and their states across time, and then you can use those along with some of the other charts like GPU metrics, and configure your Prometheus to scrape these metrics for a certain interval, and you can have these exported and be visualized in your cloud provider or your own installation of the visualization tool that you have. Here I've just gone over some of the like things that you would need for monitoring, like mostly resource utilizations, like DCGM exporter is mostly for GPU metrics. It comes from NVIDIA, and they have an open source version for doing that. It's a very simple, it comes up with its own daemon set, which gets installed on the GPUs, on the GPU nodes, and it scrapes whatever workloads utilize those. Yeah, and this is some of the other things, like you have C Advisor also, which gives you resource utilizations. Earlier, this was a community project which was outside Kubernetes, and people used to have to install it to get like real-time utilizations of like CPU or memory utilizations. Now it is all merged into the Kubernetes kubelet, so you get all this out of the box. You just have to configure your Prometheus to have a target for C Advisor, and you have metrics being available from all the pods that actually run on your Kubernetes cluster. And like once you have all these metrics, you want to have some way of persisting if you want to if you have a need for surviving crashes and be able to still use some of the data which is scraped by these monitoring tools. So there are ways like you can send it to the hosted solution, or you have your own persistence for it. And like I mentioned, like there are like well-known Grafana dashboards which you can use. It's widely available for how these are basically like PromQL queries which you can just use in your visualization tool. And most of the tools have PromQL like query, and you can use that to monitor most stuff. Internally, we have a published in our open source repo, we have like a Flyte user dashboard, which gives you a direct mapping from your Flyte workloads to the Kubernetes pods. And this is one of the examples, like it goes over the resource consumption of the memory and how it uses like your project domain, which is a Flyte concept, and the workflow, and computes like gives you a query which gives you the memory utilization percentage for your Flyte workflow. And it uses some of the existing mechanisms that are there in Flyte to tag your pods the right way to extract this information, and community can use this as a tool to create their own monitoring. Going over the like maintenance issues, like you have to make sure that your monitoring solution itself is monitored so that doesn't OM. Like usually, like you have like you could run into cardinality issues where you have like scraping a lot of metrics and which have like high cardinality. You have issues with the write-ahead log being over consuming your monitoring solution. This is like usually a sub-process in your monitoring solution to survive crashes. You want to be able to manage your storage for your metrics. This is another thing that if you want persistence, and also right-sizing all these resources for your own monitoring solution so that it behaves the right way when you want your data. Yeah, I mean, just to recap, we went over like why monitoring is needed, how do you specify resources in Flytes, and different ways you could design a monitoring solution and the benefits and drawbacks. There are ways that there are multiple other ways you could be doing this, but this was one of the things that I found like would be useful for the community. Yeah, that's it from me. Any questions?
Thank you, Prafulla. That was great.
Thank you.
Is there any question right now? No. Yeah, probably I had one. In your experience, Prafulla, what will be those key signals, those key metrics we should take into account when because I feel like, yeah, workflows and tasks and etc. I meet a lot of events, but yeah, besides probably the platform level metrics of CPU, memory, and all that stuff, what do you think are other key signals or key metrics we should pay attention to?
So there are, so other than your resource utilization metrics like CPU memory consumptions and how your requests and limits, which are being set for in your Kubernetes pods and how they keep changing. Along with that, just monitoring your Flyte platform, there are ways the Flyte platform itself emits metrics, which are there, like you can have monitoring for those, like how many errors that you're receiving for your workflows, or what is the rate of like creation of pods in your Kubernetes cluster, and if there are any errors that are happening. So this would be specifically to like how monitoring your Flyte platform itself, like your Flyte workloads, as I mentioned, like you could, there are various metrics being published for CPU, GPU, and also like GPU has like a lot of other metrics, like you have the temperature of your GPU, how well you're utilizing the reads and writes for your GPU, so that defines like how well you're optimizing your GPU resources. So those could be like useful metrics to take out and understand how your workloads are behaving, and it's a very like the community of other monitoring solutions have made it very simple for these metrics to be easily be consumed, and through like PromptQL is a widely used way of querying these metrics. And so yeah, that's usually like what I find, like, and these are like usually updated, like if there is a new metric that is being published by, let's say, the NVIDIA DCGM exporter, it would be available in their version, and you could utilize that to get more information about your workloads.
All right. Thanks so much, Prafulla. No other question? Anyone?
Thank you.
Yeah, thank you. A copy of Prafulla's slide deck is right there in the agenda doc for further reference. Thanks so much. Okay, next up in the agenda, I'd like to welcome Jan Fiedler. I hope I'm pronouncing right. Thank you for joining. Jan will share their journey at Kineo.ai, how they've been using Flyte. So welcome, Jan. Thanks for sharing your knowledge with the community.
That's me. Thank you so much for the introduction. Thank you for having me. Let me quickly share my screen. All right, let's see. You should see stuff, right?
Yep.
Sweet. Hi to all. I'm Jan. I'm a machine learning operations engineer at a company called Kineo.ai. I'm working now for this company for a couple of years, and yeah, my day-to-day goal is really to provide the best tools that there is to my data scientist colleagues. And today I want to talk about our Flyte journey. So we're actually using Flyte in production for, I would say, a month now. And if I think about it, Flyte has been really my life the last couple of months. So first we kind of figured out how to run Flyte on AWS. Then we dealt with the automation of all deployment and introduced Flyte to the company. And lately I'm also migrating to Flow pipelines myself to Flyte workflows, which also grants me kind of a nice user experience. And yeah, this brings me to the agenda for today. I want to quickly introduce Kineo. So who are we? What are we doing in detail? Then, like I said, tell you about the story of migrating from Kubeflow to Flyte. So what was the idea? What's the purpose? How did it go? Then I want to point out our infrastructure setup. So as you can see, we have chosen the path of the multi-cluster deployment, and yeah, I'm quite happy with the setup so far, and also how our engineers are using Flyte. And I also think it's something special about our setup, and or maybe not. I'm not sure. I'm curious to hear from you. So let's dive into it. So this is us, Kineo.ai, a bunch of really cool people. I think some of them are even in the call. We are a little startup in Berlin, in Germany. And yeah, we have 3 people in sales, 3 people in the infrastructure team, including myself, and the rest are data scientists. And basically, we are providing customized AI solutions for our clients in Germany. And as a result, we work in many different projects, in many different domains, with many different use cases. And also, depending on the situation at the client, we also help with like the implementation of infrastructure to meet the requirements of individual needs of data and machine learning use cases. And really, all in all, our goal is to build an AI partnership with clients. So really helping them on their AI transformation and also on their work culture. So like I said, many different projects, many different clients, and just to give an idea what we are doing in our daily business, it's a lot of forecasting, a lot of object detection in the computer vision domain, as well as production planning optimized through machine learning. So just to give an idea what we do. Yeah, so why did we switch? Why did we migrate? First of all, we used the following slide to also pitch Flyte internally, so don't be confused with whom I want to address with these slides. We're using Kubeflow now for almost 2 years, I would say. And yeah, while we use this tool, we just identified bottlenecks, and you can see now the main pain points on this slide. But what do I mean with notebook code does not equal pipeline code? So let me first tell you how an AI partnership with our clients usually look like. So we start usually with a really small and fast project where we just gather data, tinker around in the Jupyter notebook, and show business value. And after this project phase, we put the code into a pipeline and build an MVP. And exactly at this project phase, we have the need for an orchestration tool. And yeah, for some reason, just this conversion of notebook code to pipeline code was us taking a lot of time. Yeah, also doing really simple stuff like if-else statements and loops. It was not like learning a new language, but it took us time. Another big point is that we were basically not able to develop locally, so we had to submit our runs during development against a huge Kubernetes cluster in the cloud, and this sucks because of two reasons. So first one is the engineer also needs some kind of infrastructure knowledge or support from an MLOps colleague, and we are also dependent on the cloud, right? Which is a factor of costs, as well, also a factor of speed for our development cycles. Yeah, this was something a little, it slowed us down basically. Another thing, which is what we're doing, it's used what we're doing in every pipeline. We are passing data, right? And for Kubeflow, we always needed to provision the volume, so some network drive mounted to every pod, and read and write data from this specific pod. And with a really long and complex pipeline, you ended up with the need of memorizing a lot of local paths on the volume. And this was hard to keep track of at some point. And last but not least, in our old setup, we had this infrastructure setup really where we spin up Kubeflow instances for specific projects and customers only when we have something scheduled in production. So if it fails in production, then the instance also shuts down automatically. we cannot even see the logs, and yeah, for an engineer then to figure out what's going wrong, yeah, you can calculate an hour to spin up this cube, for instance, again. And yeah, and all this summarized really feels like this, just yeah, a little slow here and there for just putting Jupyter Notebook code into a pipeline. So my MLOps colleagues and I, we spent the last quarter basically to look left and right again in the open source world for orchestration tools, and yeah, looked at a couple of requirements and compared them, and yeah, Kubeflow, Flyte, and Prefect made it in the end to the top 3. I'm not sure if this graph makes so much sense, but yeah, you can guess it. Flyte made it. Flyte made it. A new challenger entered the area, and as you can see, our main pain points are pretty much covered with Flyte. And maybe this is also first opportunity to say thank you to everyone, to the community. We are really happy with this tool so far, and now we have all the good stuff we wished for. So I think the most important for us really is to develop fully locally. So really just installing FlyteKit, connect to AWS with our own credentials, and start developing just without waiting for some cluster or some MLOps colleague to assist. We can now say NotebookKit almost equals pipeline code. It really feels much more Pythonic in a way, and engineers can almost copy functions one-to-one from the Jupyter Notebook, set the task the task decorator, adjust some input and output, and that's basically it. So this feels really nice. Also, passing data is a pleasure, since we don't have to care about local paths anymore, and also Flyte files. So just the concept of Flyte files and Flyte directories really makes our life easier on this one. And last but not least, yeah, we love a lot of the features we have now in setup, where we have in a control plane, which is always online. So also this last pain point is covered. But of course, there's more what we love. I will cover the costs in more detail in the following slides, because it's quite an important topic to us. But even now, with the setup of having our orchestration tool always online, we expect the cost to be half of it. But yeah, like I said, I will speak about it in a minute. Authentication was a problem for Kubeflow. We used Kubernetes authentication through DEX, and this basically meant that engineers ended up with one password for each project. And yeah, you can imagine how their one password looked like after some time. And now it's really pleasant to just connect through these OIDC providers, use the credentials that we already have, no more password juggling. It's something small, but yeah, less passwords. I mean, who doesn't like it? Last but not least, the ecosystem. I'm a huge fan of map tasks. I also heard rumors in the data science team that nobody actually likes to write a Spark job. Yeah, we will probably use it in the future still for really big data, but it's still nice to know that there's something in between. So that would be the map task. We also like great expectations, so that it's natively supported, even though we are missing kind of the data docs, maybe as a Flyte deck, but I think I've seen this somewhere already. So probably a thing for the future. Now we are doing this on our own. But to sum up, in Kubeflow, we develop and maintain a lot of Kubeflow components for ourselves, and this need is now much smaller because of native features and integrations with Flyte, which is awesome. Yeah, like I said, the costs, 90% of our projects are happening in the cloud. So of course, we are really interested in to spend as little as possible for just a tool. And I think Flyte, yeah, I think we were able to reduce the EC2 instance at least one or twice. But actually, this base operation cost does not matter too much for us. It's more about the costs, the cloud costs during the development. So just being able to develop fully locally, our AWS costs drop drastically. And to give you an example, this is in a report, an historical report of us developing a data pipeline for 2 weeks. And you can see mostly it's just EC2. It's just EC2. It's just the running Kubeflow cluster. And this costs can be greatly reduced now. So on this obviously also scales with developing in machine learning forecasts. I'm not saying that all costs go now down to zero, of course not. But how now projects are going, what we have seen already now from the team is that we develop with a subset of data, make use of the great caching of tasks. And then only really in the last day of a project, we take the workflow online basically, and which also goes really, really fast because we have everything in the Terraform module, but we'll talk about it later. And so we can basically reduce the time being in need of this Kubernetes cluster from maybe 10 days to 1 or 2, basically. And this is great, of course. In addition to costs for cloud resources, we also decrease costs for personal resources. People just migrate Kubeflow pipelines in a couple of days. So this is what we have seen now in the team, but also new joiners are adopting to Flyte super quickly. It's really, because we're just dealing with Python, it just enables the engineers to be much faster. All right. Then let's talk about our multi-cluster setup. Like I said, we are having many different projects with many different customers, and this leaves us with a couple of major requirements to our workflow orchestration tool and our setup in general. So the first one would be we would like to let engineers without major infrastructure knowledge to spin up tools as fast and as pleasant as possible. We want to keep the data, the customer data, still in the dedicated accounts. And of course, we want to be still cost efficient as possible. And what we did now, it's also documented and recommended for Flyte. So to go for this multi-cluster setup. And we have now the control plane with the Flyte admin, scheduler, data catalog, and I believe I'm missing some other service. This is online in working hours, so it's all accessible in some Kineo central account. And the data planes, these are with the Flyte propeller. These are really just getting created and destroyed dynamically when there's something scheduled. And this dynamic registration and deregistration from the data planes to the control plane, it's really working out quite well for us. It's really just creating a cluster EKS, install the propeller on it, and then dynamically register it, do the workflow, deregister, and shut down again. And the benefits, of course, are just being super lightweight on the control plane, still keep the data isolated in the data planes. I'm not sure if it makes so much sense to connect a data plane on Azure to a control plane on AWS, but I think you could do it. We are fully in AWS now, but what we definitely will do in the future is like having a data plane on premise, and just connect to our control plane in the cloud. I'm a little conscious on time, but I think we have the time for a little demo if you don't mind. Because I just want to quickly show you this dynamic registration and deregistration of for the data plane to a control plane. So let me quickly show you that I'm connected to AWS. I'm quickly getting the kube config for the control plane, and then show you and hopefully empty cluster config YAML file. So yeah, that's now a control plane without any data planes connected to it. And I have a code pipeline in the background. So this is one resource that comes out of our Terraform modules. So this basically takes care of the automated creation of the data plane. So first it's quickly this transition while I speak. Basically it checks out the repository, enables some Datadog monitors, and then, like I said, really deploy the cluster, install Propeller on it, and yeah, then register the data plane to the control plane, update the execution cluster label. This basically tells them the Flyte admin, okay, this data plane belongs to this specific Flyte project and this specific Flyte domain. I'm sure this takes a while now. I also have some workflow laying around. It's already done. It is. So here we are. It's connected, and yeah, now I could really easily just connect to this, or just hit my Flyte run, and it should be there. Oh, and it is not. That's unpleasant. Let's see. If you see it, let me know.
Hey, Jan. So it's complaining about the CRD definition itself, not in the cluster, and that gets created when Propeller comes up. So I'm guessing Propeller isn't up yet. Can you check in the cluster? You may have gone too fast, I guess.
I have gone too fast. Maybe I should also have waited until, but I thought this record kind of should be saved in the database, so I thought I could skip it. But let's give it another try. If not, you have to trust me that it's working.
We trust you.
Yeah.
You trust me, perfect, and you trust for good. So here it is. I was too fast, indeed. And here we see our cluster. So it is running. Let's not wait until this is finished. This workflow. So this was just a little demo. Let me continue. Yeah, to make our lives a little easier, we put everything into Terraform modules that are taking care of the automatic deployment of control data plane. And what's really exposed to the user, to the engineer, is the AI Factory project module, we call it. And this is, yeah, the idea is really to use this module and hide any complexity of submitting workflows to Flyte to the engineers. So the engineers should focus on developing ML solutions and not learn how to use Flyte run or Flyte register. So engineers can go check this AI Factory project module in their use case repository, develop locally until the workflow is looking all right, provide some inputs to this module, to Terraform apply, and yeah, you get a proper machine learning CI/CD pipeline out of it. So yeah, it's also checking out your code, building your base image for Propeller, building a test image, running tests, and yeah, packaging the launchpad, register it. So yeah, that's the idea, to not worry about anything as an engineer. And this is looking out great so far. Yeah, to really sum it up now, I talked a lot about a lot of successes already, so I'll make it quick. So we are still cloud independent, which is really nice. We stayed in the Kubernetes domain, so no knowledge is lost, and they are less dependent on external tools. Like I said, great expectations, Spark, less costs, a great reduction all in all. We see a great reduction also in code. So like I said, we migrated from Kubeflow to Flyte, and yeah, I don't have numbers, but it's just less and less code. It's always nice. Faster development cycles, and the most important thing, happier engineers. So the internal feedback so far is really, really amazing. Maybe some feedback really quick. We had the feeling that the notification setup felt a little awkward to set up, and we were also not the biggest fan of having the notifications with a mail on Slack. We are currently kind of abusing the SNS SQS of Flyte admin and send notifications ourselves using a Lambda. It would be great to just have support for webhooks for common messages like Slack or Microsoft Teams. But I think this is also already in the pipe. I've seen it somewhere or in some chat. If feedback from the engineers was that the Flyte cat error messages are sometimes a little long and hard to identify. It's mostly if you forget to set the task decorator or some input value of some task is not properly set, then it's really hard to figure out at first, but I think it's also something rather small. But something bigger is, of course, some role-based, some system of, some role-based access system for Flyte projects, because we have now the problem with customers that they want to collaborate with us, and then we have to spin up individual control plane, because they probably should not see the other projects. This is about the feedback. Division between sunsetting Kubeflow, so this is still ongoing, and we really don't want to support Kubeflow and Flyte. It's obviously then getting rid of the last Kubeflow pipeline, but another big goal is launching Flyte on Azure. So basically having the same setup that we have on AWS, we have it also on Azure, because we have a lot of customers that are like at home at the Microsoft domain, and then they don't want to move to AWS. We maybe want to dynamically create and delete the data planes, because the way it is right now is that we have to take off two schedules. So the schedule of the actual workflow and the schedule of the creation of the data plane. And we had this idea of adjusting Flyte admin in a way to publish scheduled runs in some queue and then maybe trigger the creation of the data planes. But this will be, let's see in the future if this is really worth the time and adjustment. Let's see. And last but not least, Flyte plugins. So we are not sure if we should use them. Maybe we can also cover this now in a second, because our current approach to not reproduce code in workflows is to use just functions from our own Pipey server and then use it in tasks and still let the user decide on task resources, caching enabled, yes or no, and all these things. And we're still not sure or haven't figured out if Flyte plugins really make our lives easier on this one. Happy to discuss it. Thank you so much. This was it.
That was great. Thank you, Jan. Any question, comment?
I have one question. Here, Eduardo, the engineer for Flyte. I would be stoked if I could connect with you to get more on the Flyte kit error messages, because this is one area that we've been investing in. It would be great if we could cover more cases. So I can ping you offline. It's all right. We don't have to go through it now.
So hi, Jan, this is Martin. This is pretty amazing to see what you have done in such a short amount of time. I'm with Union here. I have just a question. So you might have answered it earlier, but I might have missed it. But how long did it take for you to evaluate? I think you said like something like 2 months, the Prefect versus Flyte versus Kubeflow. And who was involved in your evaluation there? Was it just you, or was it a bigger team? Can you tell us a little bit about, who made the decision then at the end of the day?
Yeah, I'm not so sure, but we made the decision quite quickly, I would say. Maybe also 2 or 3 weeks. And yeah, it was basically me and 2 other colleagues from the MLOps team. And to be fair, I was not part of the research. This was done by someone else, but yeah, in the end, 2 to 3 weeks for figuring out and comparing all the requirements, and then the 3 of us did it.
Fantastic. And then you used Kubeflow before. How much of the code were you able to reduce when you brought over Kubeflow tasks to Flyte? I mean, was that a reduction of boilerplate code that was significant to you, or was it just like the same amount of code that you came up with writing?
I would say, I think Kubeflow we say operations, and in Flyte we say tasks, and this basically stays the same, right? So the logic has to be the same, but the entry point, so the pipeline code in comparison now to the Flyte workflow code, this is almost half of it. Only having for Kubeflow, like I said, we had our own components, and the thing we use the most is just a basic AWS S3 copy component, right? To download stuff, upload stuff, and just having now Flyte files and Flyte directories. Just not using this one specific Kubeflow component makes half of it, basically.
Fantastic. And a last question, so don't want to occupy time too much, but if you would work with, you might work with, data scientists who are only just focusing on statistical modeling and being more on the data science than on the ML side. Do you think, Flyte would be a more appropriate tool to get into this because it's more Python, or do you think it's still a hard step for those guys to get into and workflow orchestrate and run their notebooks and get their code orchestrated?
No, so I don't know if no the right answer, but it's just much easier. So we are still, like I said, we are still in the phase of migrating, pipelines to workflows. So not every engineer in the team has done it so far, but the few feedback I got is amazing. They already could say, yes, I'm feeling more comfortable in the Flyte domain, and I am faster. So I would say yes for now.
It's an important question, because what we see is like companies that are in research and have a lot of data science, for them to step into an orchestrator is always it's a big step, because it requires so much infrastructure knowledge and other knowledge. And to reduce that hurdle is a really important thing to make them feel comfortable running their code. That's why I'm asking that question. Okay, great. Thanks a lot.
All right, great. Thank you, Martin. Any other question, comment? No. Yeah, well, I think we're over time. Thanks again, Jan. It was a great session. We learned a lot. We'll make sure to follow up with your feedback, keep improving the project. And yeah, with that, thank you all for joining. Don't miss the next episode. We'll have Dr. Fabio Gratz from Recogni also sharing what they have learned using Flyte. With that, thank you all for joining. See you next one.
Thank you.
Goodbye.